Hello, today we'll be discussing about light. Light is intimately involving with our daily lives. Many unique properties of light are extremely fascinating. Here we will take one step closer to the wonders of light through its well-known basic properties. Light has the properties of a wave and a particle. The word wavelength is used to express the wave or undulating property of light. It is the distance that light travels in one oscillation, and it is often expressed using a unit called nanometer. 1 nanometer is equal to 1 billionth of a meter. Our eyes only can see the light that is of a wavelength between approximately 400 to 700 nanometers. This range is called visible light. The light of other wavelengths include X-rays, ultraviolet rays, and infrared rays. Though we cannot see them directly, these are also members of the light family. So there are 10 properties of light. First is the effects of materials on light: reflection, refraction, dispersion, total internal reflection, interference, diffraction, scattering of light, and lastly, polarization.
So, before we start with the examples of refraction, what is refraction? Refraction. It is the fact or phenomenon of light, radio waves, etc., being deflected in passing obliquely through the interface between one medium and another or through a medium of varying density. So today we will be doing the examples of refraction. First, let's start. Here are our materials: pencil, a coin, and a glass of water. So first we'd be having the pencil. So if we drop it, if you look at it here, it looks normal, but if you look at it from the side, it's all different. So now let's try the coin. If you look at it there, it looks normal, but if you look at it here, it's all different. So that is an example of refraction.
Reflection of the light. The question is, how do we see things around us? If I were asked about this, I would say it is because of our eyes. But what helps us see things around us? It is because of the light. But where are these lights coming from? The light is from its source, which is from the sun, or a flashlight, a fluorescent bulb, or anything that produces light, and those things were called luminous objects. Luminous objects were the ones that produces light, just like the flashlight. And the things that aren't produces light were non-luminous objects, just like the speaker, cloth, or anything that doesn't produce light. As you can see, this thing is not a luminous light, and when I turn off the lights, I can barely see it. But with the help of the light, I can completely see it because the non-luminous object reflects the light, and when it reaches my eye, it is the time that I can see it. The explanation about this is that the light strikes the non-luminous objects and the light bounces to our eyes. The perfect explanation, or the perfect example, is the sun and the moon. The moon is a non-luminous object, but how come we can see it at night? The reason behind this is that the light of the sun strikes the moon, and when it strikes the moon, the light bounces back to the earth, and we can see the moon at night. And this is the perfect explanation of reflection. That's it, guys. Thank you.
Refraction of light is defined as the changes in direction of light when it's traveling obliquely from one medium to another medium. So what does it all mean? changes in direction means bending of light. Obliquely means the light is incident at an angle. And the word medium means material. The three example of material is air, glass, water. You can use the term optical material because optical refers to light. And for refraction, remember that the material needs to be transparent. Have you seen any simple, everyday example of refraction? Or you have noticed or even tried that yourself? One example is, grab a pencil, put it on a glass of water. The pencil appears to be bent. It appears to be bent because of refraction of light. Another example of refraction is that when you stand near the pool, the swimming pool appears to be shallow because that actually appears because of refraction of light. Reflection of light. Reflection of light is a bouncing of light when it hits something. One example of this, when you toss a ball and it hits the flat surface, it bounces back. So, when the light hits something, it bounces back and the bounce light comes into our eyes. Because of this bouncing back of light, we can see things. This bouncing back of light is called reflection of light. Another example is that the sun source of light rays. So, when the rays of the sun hits the flat surface, it's called incidence rays. So, after hitting the flat surface, it bounces back, it's called the reflected rays. And that's how the sun rays of suns work.
How important is light to us? By means of food. The light carries the energy required to sustain the life on Earth. It's called photosynthesis. Vision. Without light, we can see anything. Colors. Because of light, we can see different colors, and it helps us to distinguish every object or subject that surrounds us. Vitamin D. Our body needs vitamin D to become stronger. So why do we need light? Light is the primary essence which governs and allows all life on this planet. If we receive no light from the sun, the Earth's temperature will substantially drop in a very short period of time, and all life on this planet will quickly become extinct. So, light is essential. Without light, we can survive.